Hi and welcome back to our course on piping design. In this lecture, we will learn what is a piping system, different ways of connecting pipes into the system, and the other components that constitute the piping system. Piping systems are the arteries of our industrial processes, and the contribution of piping systems are essential in an industrialized society. A piping system is generally considered to include the complete interconnection of pipes, including inline components such as pipe fittings and flanges. Pumps, heat exchangers, valves, and tanks are also considered part of a piping system. The initial design of a piping system is established by the functional requirements of piping a fluid from one point to another. The detailed design is decided by criteria such as type of fluid being transported, allowable pressure drop or energy loss, desired velocity, space limitations, process requirements such as free drain or requirement of straight run, stress analysis, temperature of fluid, etc. The supporting of piping systems require a significant engineering, design, fabrication, and erection effort. Before we can design a piping system, we need to know how different pipes are joined together. There are 4 general methods used to join or connect different lengths of pipes. These are screwed connections, flanged connections, welded joints, and socket connections. Each of these methods has certain advantages and disadvantages. Screwed connections. In this method, threads are cut on each end of the pipe and screwed fittings such as unions, couplings, and elbows are used to join the lengths. This method is generally used for pipe sizes less than 4 inches for low and moderate pressures. It has the advantage that the piping can be easily disassembled or assembled. However, the threaded connections are subject to leakage and the strength of pipe is reduced when threads are cut in the pipe wall. Flanged connections. This method uses flanges at the pipe ends which are bolted together face to face, usually with a gasket between the two faces. Flanged connections have the advantage over welded connections of permitting disassembly and are more convenient to assemble and disassemble than the screwed connections. In order to prevent leakage at flanged connections, the flange faces which butt together would have to be assembled flat and smooth. While it is theoretically possible to grind the faces to this condition, it is a time-consuming and expensive proposition. Therefore, gaskets are usually used between flange faces. Gaskets are made of comparatively soft material which, when the flange connection is tightened, will fill in any small depressions in the flange faces and thus prevent leakage. Welded connections. In this method, the pipe lengths are welded directly to one another and directly to any valves or fittings that may be required. The use of these welded joints for piping has several advantages over the use of screwed connections or flanged connections. First, the possibility of leakage is removed, the weight of the piping system is reduced, the cost of material and the need for maintenance are reduced, and the piping looks neater and is easier to insulate with the elimination of the bulky flanges and fittings. Welded joints give more flexibility to the piping design as the pipes may be joined at practically any angle to each other. Socket connections. This method involves inserting one pipe end into another. The socket connection is mainly suitable for the connection of cast iron pipes, ceramic pipes, concrete pipes, and plastic pipes in low pressure water systems. Now let's look at the various components in a piping system. To simply understand, a piping system is an assembly of various components put together with a proper method of joints, functionality to transport fluid from its source to destination. The different components put together are defined as piping components. They are designed for withstanding the operating and design conditions specified in the process parameters. Each component used in piping systems are specified in piping specification. The first component is the pipe. We have already been through their definition and types in the previous lecture. Moving on, we have pipe fittings. Pipe fittings are defined as the piping components that help in pipe routing for directional changes, size changes, and branch connections. Piping elbows, reducers, T-connections, OLED connections, caps, crosses, etc. are pipe fittings that are widely used in both piping and plumbing industries. Flanges. A pipe flange is a circular disc-shaped piping component that attaches to a pipe for blocking or connecting other components like valves, nozzles, and special items. A flange gasket is defined as a sealing material or a combination of materials clamped between two separable mechanical members of a mechanical joint, which produces the weakest link of the joint. Bolting. Bolts are the most used fastening materials for pipes in steel piping. They can be without head or with a hexagonal heads. They can either be fully threaded or partially threaded. Next is valves. A valve is a mechanical element used in piping system to start, stop, mix, control, or regulate the flow or pressure of the fluid by modifying the passage through the pipe. A piping system involves various mechanical equipment like pressure vessels, fans, heat exchangers, cooling towers, and storage tanks. Piping specialty items are basically a range of non-fitting items and components required to serve special functions in the piping and plumbing system, mostly depending upon the equipment used in the system. Piping specialties include steam traps, strainers, angle prison valves, flame arresters, special check valves, and many more. Along with these components, a piping system might also need insulation and drainage. Piping insulation. Most piping systems are used to convey substances that are at temperatures higher than that of the surrounding air. Examples would include the main steam piping and feed water piping. In order to reduce the amount of heat loss to the surrounding air from the hot substance, the piping is covered with insulation. The insulation not only retains the heat in the hot lines but also prevents the temperature inside the process plant building from becoming uncomfortably high. In addition, insulation of hot pipelines will prevent injury to the personnel due to contact with bare surface of the pipe. In the case of piping, which carries substances at a lower temperature than that of the surrounding air, insulating pipe will prevent sweating of the pipe and consequent dripping and corrosion. Piping drainage. In the case of steam piping, it is necessary to constantly drain any condensate from the lines. If this is not done, then the condensate will be carried along with the steam and may produce water hammer and possibly rupture pipes or fittings. In addition, the admission of moisture carrying steam to turbines or engines is most undesirable. Various devices are used to remove this condensate and moisture from the lines. Piping supports. Piping must be supported in such a way as to prevent its weight from being carried by the equipment to which it is attached. Pipe supports are used for this purpose. The supports are responsible to prevent excessive sagging of the pipe and at the same time must allow free movement of the pipe due to expansion or contraction. The supporting arrangement must be designed to carry the weight of the pipe, valve, fitting and insulation plus the weight of the liquid contained within the pipe. With this, we have completed our introduction to piping module. By now, I think you know what a piping system is, what are its components, different types of pipes, piping materials and joining methods. In the coming lectures in this course, we will be learning in detail about each of these components, their types, uses and selection criteria. Thanks for watching this lecture. See you in the next one.